Hello, guys. Welcome back to Adamya Education after a very long gap. Sorry that we haven't been able to be regular on this channel owing to our own educational commitments. However, we are here again to provide you quality education. And today we are going to conduct the first ever live session on this channel, and we hope that it helps you. So, the chapter that we are going to learn today is the first chapter of Chemistry Class 10, and it is the periodic table, periodic properties, and the variations of properties. So, before we begin with the chapter, let us see what answers we are going to get in this chapter. First of all, there are a few questions related to periodic table, and we are going to answer all these questions in this chapter. The first question is, what is the periodic table basically? Why do we need to study the periodic table? Who has made this periodic table? Or what is the importance of this periodic table? What are the things which are present in the periodic table? And after studying about the periodic table, what knowledge can we gather from it? So these are the few questions whose answers we are going to find out in this session. So let's get started. So, the very first thing which comes to our mind whenever we talk about the periodic table is that it is an arrangement. But arrangement of what? It is an arrangement of elements. In today's world, there are 118 known elements to us, but there are many more elements which we do not know exactly till date. But in the near future, obviously, they will get discovered. But these elements, they definitely have some properties, some characteristics, and these characteristics have to be arranged in such a manner that we get a group so that we can study the elements in a much better way. So, this periodic table is such an arrangement of the elements in groups and periods. Groups are the vertical columns and periods are the horizontal rows. We will learn about this in detail in the later parts. But this arrangement is done in a tabular manner so that we can easily study and identify the elements along with their characteristics or properties. And these elements are not just arranged haphazardly. They are arranged on the basis of some common properties or some common characteristics. So this arrangement is known as the periodic table. And the periodic table which we see nowadays in our books or in various other charts, it was actually given by Henry Moseley. He was a very famous scientist and he has a major contribution to the periodic table. This is also known as the modern periodic table. But the periodic table which we see now is actually a lot of work, because over the years many discoverers or many scientists have worked tirelessly to find out the reason why elements should be arranged in such a manner so that we can understand and study about them nicely. So before starting with the periodic table in detail, we will first see the history of the periodic table. So first of all, there was a scientist named Dobriner who grouped elements in groups of three. It is also known as Dobriner's triads. So he observed that groups of three elements could be formed in which all the elements shared similar physical and chemical properties. So for example, if we consider lithium, sodium and potassium, we see or Dobriner saw that they have similar properties. So he arranged these three into one group. Similarly, he saw that calcium, strontium and barium, they also had some common features, common properties. So he arranged these three into one group. As a result, there were many such elements which he arranged in groups of three, and therefore it was known as Dobriner's triads. But what was the problem in this case? This arrangement was not applicable to the other elements. As a result, his grouping of triads was not applicable in the near future. Next came another scientist whose name was Newland, and he gave the idea of octaves. As the name suggests, octaves means group of 8. Let's see what did he suggest. Newland observed that when elements are arranged in increasing order of their atomic mass, every eighth element beginning from any element resembles the first element in its physical and chemical properties. What does it mean? Over here, as you can see, I have arranged A, B, C, D, E, F, G. 7 elements in increasing order of the atomic mass. That means the atomic mass increases as we move from left to right. This is the smallest atomic mass element and this is the largest atomic mass element. So if we arranged 7 such elements, and the 8th element will have the same properties as the first element. So A and H will have similar chemical and physical properties. So this was a very good observation made by Newland, but it was not applicable for elements which have high atomic mass. From calcium only it started becoming obsolete. It was not useful. As a result, Newland's observation was also not very fruitful in the near future. But owing to these two problems, or the problems which we will learn in the next slide also, finally the periodic table which we now see was formed. Next came about Mendeleev. We have studied about Mendeleev and Moseley in detail earlier also. Let's just do a quick revision once again. So Mendeleev was another scientist or another discoverer who stated that properties of elements are periodic function of their atomic masses. That means that similar properties of elements will be repeated if we arrange them on the basis of their increasing atomic mass. The same thing was given by Newland also, but Newland's octave was not applicable up to the higher elements. But in this case, Mendeleev gave a very good observation. He was able to arrange 63 elements which were available at that time, and he was able to arrange them based on their similar physical and chemical properties. So he arranged based on their atomic mass. This is a very important differentiation between Mendeleev's periodic table and between the modern periodic table. So Mendeleev arranged his elements on the basis of their atomic masses. But what happened, he was not able to give proper understanding regarding the rare earth metals, the actinides and the lanthanides. You will learn about it later. These are very special elements which have different properties, and also about the isotopes. You know about isotopes, isn't it? Isotopes are the atoms of the same element, but they have different atomic mass. Their atomic number is same, but their mass number is different because the number of neutrons are different. So he was not able to clearly say that where we should place the isotopes, and he was also not able to clearly understand that where should we place the rare earth metals. So although his idea was really a very good significant one, but it was not completely fruitful. Next came the most important one, whose name was Henry Moseley, and he put forward the modern periodic table. According to him, if we arrange the elements on the increasing order of the atomic numbers, not atomic masses but atomic numbers, then we can get a periodicity in properties, then we can get similarity in properties. And this is what we studied today. Although Henry Moseley gave a very good observation of these elements, but his periodic table was also not completely perfect. So Niels Bohr, you all know about this person. So Niels Bohr was the one who modified the periodic table made by Henry Moseley to include the lanthanides and the actinides, which we will see in the later parts, and he gave the long form of the periodic table. As you can see over here, there are certain elements at the bottom of the periodic table which are not included in the main periodic table. So this was given by Niels Bohr. Moseley was only able to give up to here. But what about the lanthanides and the actinoids? In order to accommodate them in the periodic table, Niels Bohr gave an idea. He gave the long form of the periodic table. So the periodic table which you will see in your book nowadays, that is called the long form of the periodic table. So now you might think that okay, all the problems of chemistry's periodic table have been corrected, but no, my dear, the problem is still prevalent because whatever idea was given by Henry Moseley is also not 100% accurate. You will learn about this in class 11, that what are the disadvantages of Moseley's periodic table, and efforts are being made so that a better periodic table is being made so that it can accommodate all the other elements into the same table itself. We don't have to make a separate table for the lanthanides and actinides also. So that is completely up to the time when we shall get such a good periodic table. But for now, Henry Moseley's periodic table is considered to be the most accurate one, and we are going to learn about that in detail in our chapter. So the vertical columns, as you can see in the figure, these vertical columns, these are called groups, and the horizontal rows, they are called periods. We are going to learn about them in quite detail. So there are 18 groups in all, and there are 7 periods in all in the modern periodic table. So let's see about them in detail. So there are 18 groups in the periodic table. Very important question can be asked, how many groups are there in the periodic table? So we are going to study about each group. Group 1 is known as the alkali metals. Why? Because whenever the group 1 elements are mixed with water, they will form strong alkalis. They will show a basic nature. Now talking about group 2, they are known as alkaline earth metals, and they form weaker alkalis when they are mixed with water, but they also show alkaline nature, and they are found in the earth's crust. As a result, they are known as alkaline earth metals. Now talking about group 3, 4, 5, 6, 7, 8, 9, 11, 10, 11, 12. These are known as the transition elements, the middle ones, starting from group 3 and ending at group 12. These are known as the transition elements. We are not going to study about them in our chapter. You will study about class 11 and 12. What is a very special important property of these elements? They have their two outermost shells incomplete. and we cannot write their electronic configuration on the basis of what you have learned in class 9, 2, 8, 18. That rule doesn't follow here. You will learn about this in class 11 and 12, that what type of rule can be followed in order to write the electronic configuration. So these elements which are present in the middle part of the periodic table, we are not going to study about them, and also we are not going to study about them for the reason that they have very special properties which is above our understanding at this moment. So these elements are known as transition elements, and their important property is that their two outermost shells are incomplete. They are not octet. Now talking about group 13 elements, as you can see, the first element in this group is boron. So this group is known as the boron family because the first element is boron. Next we talk about group 14, in which we see that carbon is the first element, so it is called carbon family. Group 15 is called nitrogen family because nitrogen is the first element. Similarly, group 16 is known as oxygen family. Oxygen family is also known as chalcogens because they have a tendency to form ores. You are going to learn about this in much more detail in class 11 also. So this name is important, chalcogens. Now talking about group 17, as you can see, it starts with fluorine, then it has chlorine, bromine, iodine and astatine. This is known as halogen or halogen family. We will learn why it is called halogen or what is its importance. Now talking about the most special group, which is the group 18 or the zero group elements or the noble gases. These contain all the noble gases which will not show any type of reaction. We have helium, neon, argon, krypton, xenon and radon in it. We are not going to study about this last period, so you can skip it. We just have to learn till period number 6. So that's why I told till radon. So helium, neon, argon, krypton, xenon and radon are the elements in group 18 or the zero group. They are also known as noble gases or inert gases. This is already known to you. Now we see one more important thing over here. Elements of the group 1, 2, 13, 14. Let me just mark it in the slide. So elements of group 1, group 2, group 13, group 14, group 15, group 16, group 17 and group 18. These are the groups which we will learn, and the rest is not there in our syllabus. This is not essential. Okay. So these groups which I have ticked, these elements in these groups are known as main group elements or representative or normal elements. So these are called normal because their properties are quite understandable from your understanding level right now. But for understanding the transition elements, you require a little bit more understanding power. So we are just going to learn about group 1 and 2 and then group 13 to 18. One more important thing which is something you should remember, that group 1, 2, 13, 14, 15, 16, 17, 18, you can write it in this way also. Also you can use another notation, that is you can write 1a, 2a, then 13 you can write it as 3a, 14 you can write it as 4a, 15 you can write it as 5a, 16 you can write it as 6a, 17 you can write it as 7a, and 18 you can also write it as 8a. This notation can also be used to represent groups. Instead of writing 13, you can also write 13a. So these are some important properties of the groups in our periodic table. Now let's talk about the periods. There are 7 periods in the periodic table. As you can see, it has been mentioned very nicely from 1 till 7. 1, 2, 3, 4, 5, 6, 7. So as you can see, let us see how many elements are there in each period. We will count it together. So talking about period 1, it has only 2 elements, as you can see, hydrogen and helium only, isn't it? So it is the shortest period. It has 2 elements. Now talking about period 2, let us see how many elements are there in it. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. So there are a total of 8 elements in group in period 2. And therefore it is known as a short period because it does not have many elements. You just have to remember which is the shortest period and which is the longest period. That is enough. This is just for your own understanding. Now talking about period 3 also, you can see there are 8 elements once again in period 3, starting from sodium and ending at argon. So there are 8 elements in period 3. Now in period 4, let us just count together. Period 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There are 18 elements in period 4. It has been mentioned here. Similarly, in period 5, we have 18 elements. Now talking about period 6 and 7, very important. The lanthanides have been written over here and the actinides have been written over here. So we have to count these two also. So let's see how many elements are there in period 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31 and 32. So 32 elements in period 6 and again 32 elements in period 7. So these are called the longest periods which have the largest number of elements. So you have to consider the lanthanoids, you have to consider the actinoids, you cannot skip them. Now talking about another important thing which is very useful in understanding about the periodic table. As you can see the third period, let us see what are the elements present in the third period. We have sodium, we have magnesium, then we have aluminium, silicon, phosphorus, sulfur, chlorine and argon. So if we study about these elements one by one, if we study about sodium, we can say that all the other elements of the group in which sodium belongs to the first group. So all the elements in group 1 will have similar properties like that of sodium. Similarly, if we study about magnesium, we can say that whatever properties magnesium has, the properties of the other elements in group 2 will be same. Similarly, if we study about chlorine, we can say whatever properties chlorine has, the other elements of group 17 in which chlorine lies, they will also have the same properties like chlorine. So the period 3 elements, which are sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon, they are known as typical elements, because if you study about them one by one, you can understand about the elements in that particular group very easily. So why are they called typical elements? Let's see. Because they represent the properties of their own group. If you study about them, you are actually studying about the properties of the entire group together. So very important, why period 3 is called the period of typical elements. This is a very important observation. Next, we are going to see another very important thing related to the periodic table, which gives us a lot of marks in the board exams also. How is the period number and the group number linked to the number of shells and the valence electrons? So if we know the number of shells in an atom, we can say its period number, and if we know the number of valence electrons in an atom, we can say its group number. So let us do it. Let us do some questions and let us try to understand. So I have 3 elements over here: sodium, phosphorus and aluminium. So the electronic configuration of sodium, phosphorus and aluminium have to be written first of all. So sodium has 11 electrons in all. So its electronic configuration will be 281. For phosphorus it will be 285. For aluminium it will be 2, 8 and 3. Yeah. So now let's see number of shells and let's predict their period number. So as you can see in sodium there are 3 shells, 1, 2, 3. So the period number is 3. Similarly in phosphorus there are 3 shells, so the period number is 3. Aluminium also has 3 shells, so its period number is 3. So let us just check it out if you are correct. Yes, sodium is in period 3, then phosphorus is also in period 3 and aluminium is also in period 3. So yes, we are correct about it. Now let's talk about its group. So sodium's valence shell has only 1 electron, that means sodium belongs to group 1. Phosphorus has 5 electrons in its valence shell, so its group number is 5A or 15. We know, we just studied that 15 and 5A is the same thing. And aluminium has 3 electrons in its valence shell, that means its group number is 3A or 13. So let's check. Sodium belongs to group 1. Yes, we are correct. Sodium belongs to group 1. Phosphorus belongs to group 15. Yes, phosphorus belongs to group 15. And aluminium belongs to group 13. Yes, aluminium belongs to group 13. Yes, so we are correct about it. What does it mean? That by seeing the number of shells we can predict the period number, and by seeing the number of valence electrons or the number of electrons in the outermost shell we can talk about the group number of that particular element. So over here I have a question as your homework. You can answer in the comments below. So you have to find out the group number and the period number for the elements, whose atomic numbers are 4, 19 and 16. That means first of all you have to write the electronic configuration of each of these elements, and then you have to predict their period number and group number. Now let's talk about periodicity. What do you mean by periodicity? There are certain properties in elements such as atomic size or maybe the amount of energy required to form an ion. We are going to learn about that in the next lecture. But these properties which are repeated regularly. I told you why are properties repeated, because of its arrangement. And in the modern periodic table, we are arranging the elements on the basis of the atomic number, not on the basis of the atomic mass. So on the basis of the atomic number, there are certain elements which come one after another. That means one is at the top and below there are certain other elements, and they have similar properties. So these properties which are repeated regularly, it is known as periodic properties, and this phenomena of similar properties being repeated at regular intervals, it is known as periodicity. Very, very important. This is what we are going to learn in the from the periodic table. This is the major significance of the periodic table. So periodic properties are the properties which are repeated regularly, and this phenomena of repetition of periodic properties are known as periodicity of elements. So what is the reason for periodicity? Let's see. The cause of periodicity is the reoccurrence of similar electronic configuration. That means if the atoms have same number of electrons in the outermost shell, they will have similar properties. That means they belong to the same group, obviously, because we just studied that the group number can be determined by the valence electrons. So if the valence electrons are same, they will have similar properties. That means they lie in the same group. We are going to understand about this in much more detail. Let's see. Shells, orbits and valencies. We have studied about what are orbits and what is valency. Let us just do a quick recapitulation of the same. Definite circular paths around the nucleus in which electrons move are called shells or orbits. And the number of electrons which are present in the outermost shell of an atom, it is known as the valency. And depending upon the valency, we can say that whether it is a metal or a non-metal. And it also helps us to understand that how many electrons are lost or how many electrons are gained by an atom to form an ion. So as you have studied in the lower classes also, that electrons follow a specific path around the nucleus. They move around the nucleus in circular orbits or shells, and which are named as KLMN, and it goes on. You have studied about this, isn't it? So we are going to understand how the periodic table is linked with these properties or these terms. So over here I have lithium, sodium and potassium first. Let us write the electronic configurations quickly. 1, 2, 1, 8, 1. Here we have, I made a small mistake out here. It will be 2, 1 for lithium. For sodium it is 2, 8, 1. For potassium it is 2, 8, 8, 1. What do you observe here? The outermost shell has the same number of electrons. That means all of them belong to the same group. Which group? Group 1, because they have 1 electrons in the outermost shell. So group 1. Group 1. Isn't it? So if you see that they belong to the same group, you can very easily say that they all have similar properties. Not exactly the same, but similar properties. Alright. Next, now talking about sodium, magnesium and aluminium. Let us see what is common in them. 281, 282 and 283. The outermost shells have different electrons. That means they do not belong to the same group. But what do we see? They have the same number of shells. Sodium has 3 shells, magnesium has 3 shells, and aluminium also has 3 shells. So if the number of shells is same, that means they belong to the same period, isn't it? Which period do they belong? Third period, because the number of shells is 3. So they belong to period number 3. So they will not have similar properties, but they will belong to the same period. So if the number of valence electrons is same, we can say that they will have similar properties and they will belong to the same group. But if the number of shells is same, they will not have exactly same properties, but their period number will be the same. Over here I have a question based on whatever we have studied today. First of all, this is your homework. I will tell you to solve it because we have just studied about this a few moments ago. We are going to start from question number 16. An element has 2 electrons in its n shell. So n shell numbering starts from K. So K, L, M, N. The n shell contains 2 electrons. That means all the other shells are complete. So 8, 8 and 2, right? What is its atomic number? So let's see what is the atomic number. What is the total number of electrons? 8 plus 8, 16, 17, 18, 19, 20. 20. 20 is the atomic number. Now state its position in the periodic table. That means we have to say in which row and in which period does it belong. So in which group and in which period does it belong. So it has 2 electrons in its valence shell. That means it belongs to group 2. Group is 2. And what is the period? There are 4 shells. That means the period number is 4. Right? Is it a metal or a non-metal? Obviously it is a metal because we know if the element has 1 to 3 electrons in its valence shell, it is a metal, and beyond 4 it is a non-metal. So it has 2 electrons in its valence shell, so it is a metal. State the name assigned to this group. It belongs to the second group, and second group was known as alkaline earth metals. I told you about this in the beginning of the chapter. So this group is known as alkaline earth metals. Now let's talk about question number 17. These are the questions which are generally asked in the board examination. So a better practice is very essential. Answer the following in respect to the element 3216S. That means it is sulfur. It has been already given here. Give its electronic configuration. So sulfur, 16 is the atomic number and 32 is the mass number. So atomic number is the thing which you have to use for its electronic configuration. So 16, let's see. 286, this is the electronic configuration. To which group and period does it belong? So period is the number of shells. There are 3 shells, so the period is 3. And group is given by the valence electron. There are 6 electrons in the valence shell, so we can say that it belongs to group 16 or 6A. You can write either, both of it is acceptable. What is its valency? It has 6 electrons in its valence shell. To become octet, that means to have 8 electrons. How many electrons it has to take? It has to take 2 electrons. But since it is a non-metal, that means its valency will be -2. For non-metals, the valency is always negative. You have studied about this in class 9. Is it a metal or a non-metal? Obviously, it is a non-metal because it has a tendency to gain electron. So it is a non-metal. So I hope you have understood whatever we have studied today in the chapter. With this we finish here. We are going to study about more in the next lecture, which will possibly be tomorrow. And I really hope that you understood whatever I taught here. And please feel free to comment all your doubts or your suggestions in the comment section. And make sure that you are subscribed to my channel so that you get more and more videos for your understanding. And also remember that every day we will try to be on time at 3 p.m. for these live sessions. And I hope you will all join and it will be really beneficial to you. Thank you so much.